The first graph, and I'll go over this just as we go. So parent functions. This is a linear equation. Whatever x is, y is. So if x is 0, y is 0. If x is 1, y is 1. So what's going to happen is you're going to create a line with a perfect constant slope of 1 that goes through, and that is the parent function for a linear equation on the most basic functions. Let me full screen, hide this. Okay, can everybody see this okay? I want to kind of have them all in there for perspective. Okay, the next function is a quadratic function where whatever you do x value wise, you square it. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and then 3 times 3, which is 3 squared, is 9, and it'll end up going off the graph this way. The best thing about quadratic functions is that they are symmetrical. So if I went over 1 up 1, I have to go over 1 up 1 on the left-hand side also. And if I go over 2, negative 2 and 2 squared is also 4, which creates that parabolic shape to make my quadratic parent function. The next one, since the exponent is a 3, is a cubic function. It will be very similar to a quadratic function where I start at 0, 0, I go over 1 up 1, but then instead of squaring it, I'm going to be cubing it each time, because 1 times 1 times 1 is still 1, but 2 times 2 times 2, which is 2 to the third, ends up being 8, 1, 2, 3, 4, 5, 6, 7, 8, which goes off the graph. Since it's odd, it's going to be able to calculate the negative numbers, so then it almost looks like a lazy parabola on the left-hand side, but the right side goes up to positive infinity. Okay, absolute value. Absolute value, very similar to a line. You'll have a negative constant slope, a positive constant slope, and it will meet at a vertex. So the vertex for the parent function will be at 0, 0. And then the absolute value of 1 is 1. The absolute value of 1 is 1, so it'll end up being a slope of 1 on the right-hand side going up to positive infinity. Now the difference between this and a line is instead of it being negative 1, the absolute value of negative 1 actually ends up being positive 1. The absolute value of negative 2 is positive 2. The absolute value of negative 3 is positive 3, which creates that perfect V shape that meets in the middle at that vertex. Square root function. So the square root of 0 is 0, right? The square root of 1 is 1. The square root of 4, 1, 2, 3, 4, is 2. And you'll notice that it looks like a sideways parabola that doesn't have the right-hand side. All it has is this shape here. You also can flip the page and go over 1, up 1, over or up 2, over 4, and it mocks the quadratic function, but since they're inverses of each other, their inputs and outputs also switch. Number 1, we want to figure out what function type this is. So this is an absolute value, so I'm going to put AV for absolute value. I know because it has the absolute value bars. I'm also going to list the parent function. So the parent function here is y equals the absolute value of x. So my goal is to figure out what happened here. So I have 3 transformations, 1, 2, and 3. Okay, so what I'm going to do right now is I'm going to graph the parent function, and then we're going to move it in that direction. So I'm not going to plot all the points. We know the shape of the absolute value function. So I took a pencil. You can see it here. So I have the V shape here. Okay, so that's my parent function. My goal is to take it. The negative outside means a reflection over the x-axis. This is right 3, because remember everything inside the parentheses is going to do the opposite and then this will go down 2. So I'm going to take each one of these points that I see, and what I'll do is I will graph the parent function in black ink, and I'll graph the actual function. That way you're able to see that much better. Okay. So now the reflection over the x-axis, so what will happen is it will change it from facing upward to now it'll be facing downwards. I'm going to move the vertex right here, right 3, and then down 2. So if I take this and I go 1, 2, 3, and then down 1, 2, this that I'm graphing in red is my new vertex. Instead of it facing upward, I now have to make it face downward. So what I will do is I want to have the slope of 1, but I want to face it downward. So I'm going to go over 1, down 1, over 1, down 1, all the way throughout the graph. And then on the opposite side, it will also face downward. And if you just take your time, you should be able to draw a straight line that goes through the graph. You can take it point by point, but if you know the shape of it, all you have to do is just implement the transformations, and then you get the graph that you need. Now the question that I'm going to ask is, what is the domain and what is the range? So the domain, it goes to the left forever, it goes to the right forever. So therefore my domain, and I'll put D here, I'll put it here. Domain is parentheses negative infinity, comma, infinity. And my range will be from, we went down 2, so negative 2 will be in there. But notice how, again, you want smallest number. So it's already facing down to negative infinity. So that means I will put negative infinity, comma, negative 2. Negative infinity, comma, negative 2. And what do I need to do in terms of bracket versus parentheses? The 2 needs a bracket. 2 needs a bracket. So change this to a bracket because I'm actually able to hit it right at negative 2. Okay, let's see what you got. So number 4, I know that I have a reflection over the x-axis. I know that it goes up 9. X is squared, making it quadratic. So my parent function is y equals x squared. And then my rough sketch of this graph will be a parabola facing upside down because of the reflection. Now, if you notice on my graph, I have plotted the original points to my parent function, but we need to make sure that we flip it over the x-axis, aka reflection, and then we also need to make it go up 9. So we already know that it's facing upward and we need it to face downward. So let's just take the vertex up 9 now and then graph it upside down. Okay? So I'm going to take the vertex up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to graph the pattern downward. So over 1, down 1 on both sides. Over 2, down 1, 2, 3, 4, because 2 squared is 4 on both sides. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I were to go over 4, how far do I go down? What's 4 squared? 16. So I would have to take it down 16, which if that's 9, that's 10, 11, 12, 13, 14, 15, 16. Okay, so now I'm going to graph the new function, which is a reflection of the x-axis and up 9.